The people here, if not, please come in. Okay. So my name is Luis Bermudez. I am the thread lead of the cross-community interoperability thread. I also did some work with Luke. He was sub-thread lead, or lead of the sub-thread of part of CCI, which is the Hydro part. And also Jane Harn from Lockheed, she started leading these activities, so she's not here, but I need to acknowledge her. So we had a great group of sponsors. As always, I very much like to say that their involvement is critical for their success of these activities. And we have great participants that created the components and created the reports. And most important, what happens in these activities is we start with an idea of we're trying to do, for example, provenance, how we're going to do it, and we have a crazy architecture, and in the kickoff we think about it, in the telecast we think more and more and more, until something, a light comes on, and then we had a great idea, and then we go ahead and implement. So it's great really to have this group of very smart people. So this is the summary of the work. So I'm going to provide a very high-level summary. I'm going to touch in some of the most important points because a lot of the things I'm going to talk about will be shown in the demo. So I don't want to be repetitive. So how many of you are aware of the work we did last year in CCI Testbed 9? Raise your hands. Oh, okay, so very few. So this was a continuation of the work we started in the Testbed 9, where this was the third testbed that we were playing with ontologies and see how they fit together with OGC services. So in OWS-10, we had the activity of, we have two models. This was the NGA topographic data store and USD national map, and see if we can encode the relationships in ontologies and then be able to mediate among them. So if we have the styles for one of the models, this was the NDA styles, can we portray the other model with the other model styles if we do the attributed conversion? So that was very interesting. Then in the next testbed, the previous one, we did a little bit more work and we expanded to other areas. And in this one, we really, I think, took it to a next level where we, for example, were able to use that technology to link the features to other data that is in the world, crowdsourced data, and so forth. Not only that, but when we were trying to think about how provenance works, and I'm going to touch on some points like, for example, conflation, when we have two sources from one same region that are different, say, hey, we need to do something, which one should we use? Then we apply a smart algorithm, we conflate, and we have a result data set, but what do we do with the history? How the process was done, what web processing service, what algorithm, what. So how do we capture that provenance in the WFS server? Now, in the client side, in the WPS, in the catalog. So there was a great discussion. So we use a SparkQL server, which is our D servers that are good to capture resource description framework idea of triples. So you can imagine that we did the conflation and then the result was stored in that SparkQL server that then somebody else, another client, when the client is looking at the WFS features, will ask that SparkQL server, hey, let me know what do you know about that feature. And then it will crunch all the triples knowledge base, and we'll get information about, oh, that feature was conflated yesterday by this process, by this person because of this and that. So that was also related to ontology. The second part, voluntary geographic information, we tried to get data from Flickr and Twitter. to see if, for example, related to a point of interest, can we get also images and tweets in that area. Also in the gazetteer, we use other sources of data, which I'm going to show later, and we also advance sophisticated searches such as we did in the previous test bed. So we want to do a radial search, we want to see how a virtual gazetteer works, but we want to coordinate other gazetteers, how the query spans through the sub-gazetteers, and so forth. I already explained a little bit of conflation, and so let me walk through, so first I'm going to tell a little bit about the components. So we had the client, and this was for the gazetteer, for the conflation, for all the thread, was that Pixel's innovation and the worldview, so thank you. We had services for virtual global gazetteer from Science as well, in kind. WFSGs, this is gazetteers, right? They're served via WFS. We had 3, one from NDA, one from USDS, and one from New Brunswick. There was a local one. So Interactive Instruments provided one, and the other ones were provided by Compusol. We had a catalog. Also Compusol provided the WFS for the national map. We had some profiles, DigiWiki profiles that were provided by Interactive Instruments and also by Envision. We had WPS, Web Processing Services, right? WPS2 that allow us to do the conflation, point conflation and line conflation. These were provided by 52 North and Arizona State University. We had a VGI component that was able to get all these crowdsourced data and put it for the linking WPS. This was by 52 North. We had a great work on semantic mediation by Image Matters. Stefan did a great work and doing a lot of work putting the SPARQL servers, like one for getting the link data, one for provenance, try to see if we can, for example, wrap a WFS and GML in RDF to make it available via link data as well. I worked on a core data model using some work that was done into SPARQL and to see if we can capture, for example, other models. I don't know if you were at the LEAPS meeting, but there's, for example, some models coming into OGC, and this is like a very comprehensive model. I don't remember the name, but from the Abu Dhabi police, which has a lot of classes and a lot of attributes. So can we have a core model and we're able to represent those sophisticated models in, for example, RDF? So that's all the work related to ontology. For the hydro mediation, we have Inside University and CISRO. So there are 2 models. How do they interpret if they want to do some, for example, calculations in an area? And these are the engineering reports. And as it was said before, we have not finished this activity. I think only one is going to go right now to the profiling interoperability ER. It's going to be voted, but the others are work in progress. I hope we have all finished by the end of April. So let me talk through some of the, I think, cool things and things we need to highlight. And this is the gazetteer linking concept, for example, where if we have a gazetteer, it has a name, then how do we get similar data, for example, more information from other sources such as DBpedia, OpenStreetMap, and so forth. But that was very interesting, and we used RDF to be able to link. So we knew the IDs of each feature, and we knew the IDs of these crowdsourced, let's say, gazetteers. So we had a way to link them so a client can ask for, please tell me no about this feature in this crowdsourced source. So that's how we did it. A lot of work in profiles. So if you know, profiles is maybe an extension or a restriction of a standard. And we wanted to see first how difficult it was, for example, for a client to interact with those and to do some testing, validation that the profiles have some interoperability in the systems. And I think it was pretty easy for the worldview just to interact with the profiles, as well as one service that was just a plain service. This was for the digital nautical chart. So we said, okay, we can bring profiles, we can bring normal WFSs, and interact with them as if they were just a simple service. So that was great. Sometimes, of course, if a profile has, for example, a coordinated reference system that is particular for that profile, and if the client does not knows how to deal with it, of course we have a problem. But most clients nowadays can deal with some of those issues, like having a list of coordinated reference systems that they support. So point conflation in the Monterey area, the idea was to obtain more information about a point of interest, and then the question was, how do we capture the rules of what attribute maps to another attribute? So we came with a neat idea. So in the previous test beds, we used a SparkQL server, and we needed to do that beforehand. So the client needed to go to the SparkQL server and ask, hey, do you know anything about this attribute that maps to this other attribute in the other source? So it required a lot of work behind the scenes and before. So in this case, we said, well, can we provide like rules on the fly? And maybe using JSON. So the client was able to create a form to capture the user mapping, so it showed the attributes, and this is going to be shown in the demo. So capture the two attributes, you do the mappings, and then that was sent to the WPS via JSON. I think that was very neat. So yeah, this is an example, but I'm going to show more in the demo. And then linking with VGI sources. So as I said in the gazetteer case, we had the IDs of the future, so it was sort of easy to link. There was also some work on conflation, where we tried to do some fuzzy search to see, for example, the words were doing a fuzzy search algorithm if they were similar to other concepts in other sources. So similarly we did in the Monterey case, if we have points, how can we bring other crowdsourced data? So we ran this fuzzy-wuzzy algorithm and then return the results in RDF, which I will show in the demo more details. So as I told you at the beginning, we had this idea of provenance, how are we going to deal with it? And also, as some of you may know, OGC interacts with a lot of standard development organizations, such as the World Wide Web Consortium, W3C, and they have developed a ontology and model to capture provenance, Prof-O is called. And we had somebody that knew very well that model, Yolanda Jill, so we appreciate her input very much and her participation. And she worked closely with OGC members like Joanna Massot to try to create a profile of that W3C provenance model. And we have it in GitHub, in the OWS-10 GitHub, where we have all the RDF, this is in N3 or Turtle, where you can look at more details. So that model provides, for example, how do you capture the process input? How do you model the process output? How do you model a developer? How do you model that WPS is service, for example, is a plan? So all those, let's say, concepts and conceptualizations can be captured in this model, and that's how we store that provenance in a SparkQL server. So then, what's next? One is investigating improvement of performance. So still we have the problem, so how do we deal when we have millions of features? Can we page? Is that maybe the best way? There is a new working group, there is a global grid systems. Can that work? Can we explore more geosynchronization that was done in the past? Can we maybe use your package to be able to synchronize or do more sophisticated queries and advanced WFSG best practice for languages. Also, the idea is how do we better exploit what we have done in terms of SparkQL, and can we create common patterns across OGC services so we can say, if you have a WS service, this is how you can make it link data. Or do we need something that interacts with WFS? How do we capture the GML models in RDF, for example? So all that is work to be done in the future. But you can think that WFS maybe has an output that is RDF, or a link that it advertises in the get capability to say, this is my link data link that you can interact in a more, REST way. I don't know. But that is some ideas for you to think about it, and maybe for testbed 11. Advanced provenance model, that's another point that we wanted to do in the future. So right now we're capturing, let's say, minimum information about what was done, what was the source, the target of the configuration, what was used, who pushed the button, what was the reason, what algorithm was used behind. But if we want to know, for example, queries such as tell me how this feature was in this event, and if somebody from other organization have changed it, or more sophisticated queries, we need to play with time inside the provenance metadata, or any other advanced provenance queries that we can think of. DigiWiki profile, so maybe testing web coverage services, and also the idea of, well, we have in OGC this testing facility. If you don't know, is the testing facility that implementers use to get certified. So if they pass the test, they can get the certification. But right now, it doesn't test profiles; it tests only standards. So how do we, for example, change that web testing infrastructure to allow communities to, for example, register their profiles and allow the community to test those rules that are on top of the existing standards, for example. That's another idea. And also advanced WPA standards with at least 2 profiles, and it has been talked about. So now we have experimented with WPAs, we have experimented with configuration, we have experimented creating geo package, using WPS on the cloud, very cool. So what's next in terms of OGC, and what do we need to do? So we need to move forward, and some of the ideas, for example, creating profiles. Profiles that have specific rules, and that people can look at them and say, okay, I'm going to implement the WPS for your package. So that is concrete. It tells the implementers how to do it, and so forth. And also, if we're going to do that, at the same time, thinking about reference implementations that other folks can look at and learn when they are implementing. That's it. So then demonstration. And any questions? So we finish this. Raj? Is Johannes on the line? So we have prepared this demo. Most of the times we create a story. It's not sometimes super real, but it's a story to capture what we do, so it's fun for you, fun for us to tell the story in a nice way. And so we try to do here a cross-thread. This is CCI, Open Mobility, Cloud and Aviation, and yeah. So we can start. Then we have other demos, one for hydro and one for gazetteer, which we were not creative enough to put them all together. So we're going to go through these topics: profile, semantics, conflation, provenance, linking, geopackaging, field annotations, geosynchronization, and cloud-based imagery processing. So Monterey, again, right? So we have done these several times. We love it, it's a beautiful place, right? 30,000 population, it can go to 70,000. You know, this is where you go to get wedding pictures if you want to get married. It's a beautiful place. But most important, if you see the blue, dark, it's nice, rich canyons with, you know, a lot of rich habitat. This is where the whales go to have their gala anniversary dinner. It's really, really good. I used to live in Monterey, and I worked for the Bari, and they love this canyon because it was a playground for scientists. So there are some state marine conservational areas, very important for setting state. And so at the same time, there are some naval vessels in the area. So they're working with the naval prescribing schools on, you know, some activities. And at the same time, right, there is a cargo fire collision with an oil tank, and you can imagine, right? So this is a big problem, but it's going to happen with the folks that are on the vessels. There's going to be an explosion. There's going to be a problem, you know, in the air. The habitat is going to be, you know, problematic. So the first thing that happens is that the U.S. Coast Guard gets notified. And for those of you that are not familiar with OGC services, well, we need to create some base data, and we use, in most cases, OGC Web Future services to get, you know, polygons, points, and OGC Web Map services to get images. And the analyst needs two things: needs fresh imagery, right? Something when an event like this occurs or others, the first thing is we need fresh imagery. And the second one is, needs to get data from US government and the NATO allies, because maybe they have data that can be helpful. So,
So this oil spill just happened. The first thing you want to do is, obviously, where's the oil? This is a national marine habitat. You know, it's really important to protect the wildlife there. So, to know where it is, the Coast Guard decides to send out UAVs, take some quick imagery, understand where everything is. So they take those, they send those UAVs out, download some raw imagery, and remember we talked about that orthorectification service. Let's send that imagery out to the orthorectification service, put it in a cloud so it can be done in minutes, get all that orthorectified, and then put it in WMTS for access by all the participants. Not only can you get, as I mentioned, not only can you get mapping services to that WMTS, but it could be the input to a geopackaging WPS process. And once those people go out there in boats to do something about the oil, they're going to be offline, they're going to be disconnected, so they're going to need that in a geopackage. So is it back to you?
Make it interactive. So now we need to get data from US government and the NATO allies, and we do this via profiles. Remember, these profiles can be restrictions or extensions. It's really a standard, but a little bit more. As I said before, for example, defines the maximum width that you are allowed to get an image, or a cartoon reference system, or the formats, sometimes more. So we get the data, because the world view, or the analyst in this case, gets data from the sources, so DigiWeek profile WMS from Envicia, the UK Mod Marine profile WMS, the DigiWeek WMS profile, DigiWeek WFS, which is also a transactional profile, and the Digital Nautical Chart WFS. So this is showing the client is interacting with all these profiles, so it's opening the data. Here you're seeing the marine profile, the UK mod. Now the NGA DigiWeek profile, and then matches all the data. So how can these impact aviation operations, Johannes?
First of all, let's see about aeronautical information. So certainly for this incident, the airspace around the location could be restricted and closed. So you can hear me okay, I guess? Just so that operators from other aircraft that are related to the incident, like monitoring aircraft, etc., rescue operations or whatever, can be conducted safely. Then a digital notem related to this incident, for example, that the airspace is restricted or closed, that can be published and disseminated. Then also stakeholders like authorities, dispatchers, and pilots could retrieve further background data from the system itself. For example, about airspace routes close to the incident location. And then this aeronautical information can certainly be visualized as well, as we've seen in this previous video, and also take into account the temporal nature of aeronautical information, which is quite useful for planning. Right, so moving on to weather information, conditions and forecasts for the incident location that may need to be checked to figure out if any aircraft operations to deal with the incident can safely be conducted. Also, the smoke from this crash fire could lower the visibility in the area, and this information could also be encoded and disseminated. And last but not least, flight information. So flight plans of regular flights could be amended so that they avoid the area of the incident, and these amendments could then be published to everyone who's entitled to get this information and is interested in this. And also flight plans can be created for the search and rescue aircraft that I mentioned before. Right, so next slide. So this is really just an overview picture. So all of the, let's say, procedures and operations that I just described for the previous slide are backed up by our OGC aviation architecture, which is based on OGC ISO standards. And this architecture, as we've demonstrated in this and previous test beds, allows us to, in general, discover, access, manage, publish, portray, process, and secure aeronautical weather and flight information. So much from me. Back to you.
Thank you. Thank you. Okay, so now we're going to run an oil spill model, and for that, those of you that know, we need, wind data to have the wave model, but we also need the shoreline because boundaries are important when you want to run these models. So for the shoreline, we have two sources: the digital nautical chart (DNC) and the NGA TDS. But if you see carefully here, now that we can zoom, they do not overlap. So there is a little bit of misalignment here. So what do? We do conflation, and this is what we're showing here. We're showing the two sources, and then the world view, you can select different processes. In this case, CCI. You pick the feature types that you want to conflate, and you invoke a web processing service. This is the WPS from Arizona State University, and then you can see the results. Let me expand in this. So if we zoom to what we're seeing here, a black line was created, that's the conflated result, but also you can see some orange segments, and that tells you which point was conflated with the other point, source and target points, and the point that was created in the dark line.
Okay, so once you have all the input data sets, the dune, the waves, the shoreline, you need to run the oil spill dispersion model, and that's where another one of our web processing services on the cloud comes in. And North was able to, I don't know if they actually have their own spill dispersion model, but the idea is that they would be able to run that very quickly there. And running on the cloud allows you to get results in near real time so that you can get out there as quickly as possible and use your boom and skimmers, whatever you need for oil control, protect the most sensitive areas of this So our results for that, they identify that the spill is going to kind of go around the top of the little peninsula, and that's actually going right towards the most sensitive environmental areas. And so we need to notify the protection agencies. So we've got to get that plume out to the people who need to go out there and take care of the animals. So once again, that's a great place to use the geo package, share it with all the responders, all the responsible parties, and stakeholders, get that onto mobile devices, and get some ships out there. So I went over this in my threat overview, but as you can see this geo-packaging WPS architecture. You might have a Coast Guard who has, the best viewpoint on all different data sources, running that WPS, creating the geo-package, and being able to distribute it out to NATO and all the other parties. And now that we have this interoperable format, everybody can take it and view it in whatever client, in their preferred client. Here we have Envisionability Great Client, which actually uses an OWS context document. It's original, I think it's Adobe, so the original version of the OWS context document is situational awareness. This is just a way to see on a map the same view that somebody else is seeing. So it's a way to share your data. Where you zoom to things are turned on and off. And then you may have another client, the National Marine Fisheries Service, going out there and creating, this is the same data in a different client, but also what we're doing here is annotating places where we observe, animals or wildlife that have been affected by the spill. And so Luciad has a client where you can actually create new information in the geopackage, create imagery annotations. And I think this is real. I think you can actually create these imagery annotations in the geopackage. And here's yet another client from Clouded. This is an HTML5 web-based client for viewing geopackage data. mantling. So you have 3 different client schemas which you have the same geotagging information. That's a big part of our interoperability.
Good, so now we're going to move forward to the inland coordination, right? So the marine life is important, but also the people that are in the monorail area. So there's this problem that maybe an explosion is going to happen, so we need to know where the fire stations are. We need to assess if a monorail is prepared or not. So for that we have 2 sources, engage data store and the national map. And using here the point, location for the fire stations, and they complement each other. So we're going to do similar to the name conflation, we're going to do a point conflation. So again, we are looking at the world view client. So we see that they are based on different schemas, the 2 points, green and yellow. Oh, I forgot something, so I'm going to go back one slide. Yeah, so I was saying that it's, I forgot to say, it's TDS building 2 points are going to be configured with fire stations. So there are different feature types in 2 WFSs, but we were able to do this conflation, and I'm going to show the movie again. Sorry to be repetitive. So the 2 points are based on different schemas, as I said. We can take a look on the left side about what are the attributes for those features, and then you invoke some of the processes that are available in worldview, such as CCI conflation, and you select the feature types. And then this is very interesting because this is where I told you that you can create rules for the attributes almost on the fly. So you map these attributes. So let me explain a little bit more here. This is a summary of what's going on. So you can see sometimes the source and the target have the same field like others, but sometimes no. It's your new name, member to name, full name, maps with name, or sometimes you need to add an attribute. So all that was done on the fly and was sent to the WPS via coded JSON. So let me continue with what's going on. So now that you finished the conflation, you went to the web processing service, in this case from 50 to north, and that's where we exercise the provenance in the RDF. So the WPS also returned the provenance following the product from W3C, and you can get more information about what happened, right? Source, the target, and you can investigate further the process. For example, here it says that 19 fire stations were added. So the user gets this real good feedback, and then the user proceeds to, okay, so I'm happy with the results. And then I want to update the results. So as I said, the provenance ontology, provides this data at the classes, for example, that says, you can have an activity, an entity. The process can be associated with somebody, so you can capture all that. You can also provide the server point where you do the transaction for the WFST. You need to provide the endpoint where the provenance is going to be stored, so the SparkQL server that I was telling you about before. So here the user is annotating that process, so it's providing the user name, it's providing some comments in order to update these in the provenance SparkQL server. Here you get the result that there was a OWS-10 transaction and the SparkQL update was completed. So SparkQL most of the times is used for query, but there's also an insert operation that you can insert through this. So you can take a look then at what happened, and you will see that the attributes, the new attributes value appears, and it's all now configured into the target source. And we use the OWS-10. This was a DDWIP profile as well. But in the OWS-10, what happened is that, for example, we add a geometry, this is, for example, a new point, or a value. So we're able to exercise that. Now, another part that is needed in this incident is, so what's going on in the area that people can tell us about. And this is why it's called volunteer geographic information, which is basically a part of this crowdsourced data created by citizens that are around the area of interest. And we can take that AGI data as a new layer on top of what we already have, all the images and vector data. So we use for the Monterey case Flickr and Twitter. So we're able to link a fire station with an image, for example, in Flickr, or a tweet from Twitter. And this is how it looks in worldview. So when you are looking at the future, there is a link here that says, link to images, and then you can take a look at all the images related to the future. So that was built in worldview. So the other part, Raj, is that we exercise with augmented reality. So for those of you that are not familiar, is, well, if you have, for example, a phone and you are in an area, can you know more about the thing that you're looking is pointing with your phone? So augmented technologies participated in testbed, and for example, you can get this type of information if you're just walking around. So okay, this is fire station, and where is it located? This is fire station 5, and so on. And for example, you can tweet about it and can provide more information to the emergency responders. So it's a very nice way to include your surrounding with data available from the server. So now the analyst is very happy. The model run, we have an updated coastline, we have all the fire station areas, we have assessed the situation. The Coast Guard's went with the geo package, they have already annotated some of the for animals affected by the oil spill, some oil spill, and so that's the end of the story. Thank you very much. So now we are going to look at the hydro and density.
Hello, my name is Perry Peterson. I work at Texas Innovation, and we were the client that supported many of these services. And if any of you worked on these test beds as a client, you know that what I've been doing is working all night. And I think about 5:30 this morning we finished a few of these videos. So I wanted to give you the impression of what it's like to run at full speed, the applications. And so this is really a live video. It's sped up about 2 times, a few places a little bit faster because we've got compressed time. But it really speaks to the types of power that Open Web Services now is giving us. You know, it's no longer, you know, press a button and go have a coffee break and come back. So we're really pleased with that. I'm going to let some of it go, but I want to just acknowledge as we're going through here some of the players. This is the Global Gazetteer team, and so many of us spread out all over the world, as happens in these test beds, put together some tremendous technology. And the scenario here is that, unfortunately, this seems to be repeating itself in history, but in 1755, the British Empire was looking for the folks who lived in what's present-day Maine and New Brunswick and Nova Scotia, part of the Maritimes in Canada, the Acadians, they were French people, to pledge allegiance to them. And when they refused, they secretly one day got them all into different meetings in different towns. They took every male above the age of 10, put them in ships that were waiting for them, and sailed them off and expulsed them from Acadia. And so that's a pretty sad event, and we have a nice map to show how those people were dispersed throughout the world. Really, they were sent to New England and to France. Many of you may think that the Acadians were sent to Louisiana. But that's actually not historically true. None of them were actually sent to Louisiana. Louisiana was controlled by the, who at that time, 1755, it would have been Spanish? It was Spanish. But these French Acadians were dispersed in New England, and even when they went back to France, they decided they wanted to get back together, and so they found refuge in, of course, the state that we know today as... Cajuns? No. Where do we have the Cajuns? In Louisland. So they all went to Louisland and under King Louis, and there's a festival celebrating really this expulsion called Tinta Marie, and it's in New Brunswick, held every year, and the folks in Louisland started thinking this would be a nice place to get back there, and so every year there's an influx of people, Cajuns from Louisland, that come back to New Brunswick, and a delegation is planning to come in this very year, and they need to plan for this, and so they need some interoperable services to start to make some decisions about how they're going to get there and where to go, and they're quite excited about this. And so they enlist some IT Cajuns, and they decide, you know, we're going to get from Louisland all the way to St. John, New Brunswick. So this is the heart of Acadia, and this is where they have to start to evoke some interoperable services. Now, this is kind of small on the sheet, so I want you to notice that the services that are provided here, there were 3 gazetteers. One was produced by NRCan, Natural Resources Canada, National Geospatial Naming Database, one by USGS, and one by National Geospatial Intelligence Agency. We also invoked an API on geonames.org. So we had at least 4 services that we were pulling in. And we also were building links into some of the open services through a GeoSparkle server that was built. So and when you'll see it at the right side, I want to let this go live. So you'll see at the right side as we're digging in through that wire diagram, the services that the client is evoking. Sorry, too many ums, that's the 5:30 in the morning thing. So the first thing we want to do is we make a direct link into the NGA server, and we want to search for the place name. And so we start saying we're looking for places within our area, and we get back a mixture of places that we may find. This is through the NGA database. And then we say we've got a particular one, and this is really important because we just made an RDF link to other services that are available. Linkages are so important now, and it's the way that we can allow people to mine through data. And so we've got automated linkages from the NGA code or ID for the place name through the geonames.org. And so we can grab a link and we can start browsing now, and the links give us access to other links. And now we can start to mine through some places that we'd like to visit while we're in Acadia. Find out who the mayor is, how much he gets paid, how much mortgage is on his house. Maybe this might get out of hand, I'm not sure. So now we're going to, we've got two databases. One is a database from the NGA, the other one is the New Brunswick database. Both have key codes for certain places within New Brunswick. So we need to search through both of those, but we notice that there's no linkages on the NRCan database. So when we click on St. John, there's no linked data. However, we can call on a WPS service that will allow us to exchange information between those two particular places. And they can conflate the information from one to another. Essentially grabbing the information from one, saying, these are actually the same places. Let's grab the information from the one place and associate it with the other. And so, maybe hard to see on there, but we actually have a line coming down between those square ones are from one of the gazetteers, and that's from the Canadian gazetteer into the NGA database. So now we can include the linkages that are on the NGA through to geonames.org and then on to other databases, DB, with the DBpedia, no, that's the one, and OpenStreetMaps, for example. So here we're actually pulling in from OpenStreetMaps a geometry that's linked through from the database that Canadians have to the US NGA database through the geonames and onto OpenStreetMaps, which is quite interesting. Now the other thing we want to do is when you type in the words St. John or lake, or I want to look at the mountains, the Cajuns, they don't want to have to get 15 returns from the same place. And so they need a service that can decide for them where there's duplicates. And so that duplicate is a WPS that's set up. And we're going to take a look at, oh, wait a minute here. We have a message in. King Louis declares that the Tinta-Marais, the Cajuns will reclaim Acadia's planting their flag on the highest point they can find. So now there's a new service out here. We have to find the highest mountain that we can plant this flag on. So let's just see what happens now. So now we have to find mountains, and we're going to type in the keyword summit. And it goes across the USGS database, because we're close to the United States here. It goes to the NGA database and the Canadian database. And we find the number of high points, which could be summits, mountains, rocks, Every database, of course, is using a little bit different ontology to describe where their summit is. And so these are all being returned, and you can see that this actually on the left-hand side is going into Maine, I believe that's Maine, and New Brunswick and in the ocean. So we've set a radius search on that of about 150 kilometers. And so we'll do some QuickTime stuff here, and we're going to encode this so that we have a range of values from the different servers. And so that just kind of separates some of those out. Now we will need to get some height information, so we'll have to go to a coverage server that's serving elevation data, and we'd have to grab the elevation of any particular point and associate that with the new data on the fly. So we'll have to mash up that database as well. And then we'll style it so that we have the higher peaks of a certain value. Makes it easy for us to find where we're going to plant our flag. You can see the ideal position for our flag and the elevation. And so we all get together and start marching at it. St. John, takes us a couple hours. Here's our route. There are 2 mountains to pick. And our fearless leader, King Louis XIV, part of his head getting chopped off. Nobody really knows Spanish. Plants the flag on the mountains. And then we have to plan our escape. So we have to find out where the closest airdrome or airport is. And of course, again, we have to evoke the Universal Global Gazetteer, because we're going to hit a lot of different places, a lot of different gazetteers. And after we have some partying, celebration on the hilltop, everybody painted blue, white, and red, flags and gongs, and somewhere along here we're gonna, come on people, we gotta get out of here. The New Brunswick police are looking for us. And so we do another search, find the nearest airport. And we can order those, we can rank the distances, and find the services that each airport is associated with, and then we can follow our fearless leader home. Thank you very much. Good. Okay, we're actually on to another topic. This is another of the CCI threads. It's the hydro thread, and so it's a little bit more serious because, of course, we're on the planet today. We're wanting to get as much information as we can to make very, very important decisions, and in order to do that, we need to have open services, because people are wanting to deliver their data in a format or use their data in a format that is of interest to them, but often that creates some silos. So in this particular demonstration, what we're showing is the power of we're setting up a new working group. It's a discrete global grid. This allows us to bring data in from different services, and the theme here is hydrology or hydrology. And but the interoperability is we're going to be looking at the Red River floodplain or watershed. And if you're not from North America, you may know that the Red River watershed lays right in the center of an ancient lake, Agassiz. And the lake is gone now. It was one of the biggest lakes. In fact, at one time it held more fresh water than all the lakes that exist in the world today. It was a glacier lake, and so the area there is really a big flat lake bed. And water doesn't run off very well from this area. In fact, it floods every year, and it's a topic of concern for anybody that lives in that area. So, and it's water that flows from the United States into Canada. Very few watersheds actually flow north into Canada. And so the coordination is a little bit different than anywhere else between the Canadian and US neighbors. So we're looking at some interoperability there. We have two organizations that are using different data models to be able to model all of the hydrological elements and features in their database. So we have Canada that has a database that they've formatted and features that they use, and the United States has, just pause it here so you can see, it's actually this line right here that's between, I think we're about North Dakota here, and the province of Manitoba. And so we're just going to come in here. Now, this is really important. You can't see it very well on the screen, but on the left here are about a dozen data sources. They're all interoperable data sources coming from different servers. There's WMS, there's a toporama from Natural Resources Canada. There's some web coverage services on the EO profile. So there's some satellite images, TRIM, part of Jackson, NASA's effort to be able to measure rainfall. We've got some other ones there. We have feature services, so the lakes and the riverbeds, those are all web feature services that are coming from both countries. We have point-based data that's being served through SOS, measuring streamflow, and we have precipitation data. So lots of data that we've collected very quickly and rapidly through open web services. And on top of this, it's all put on top of a discrete global grid that allows us to do analysis. And that's really important because it's not just visualization now, we can start to do some analysis. And there's a digital elevation model. It's the NEB. Americans would know what that stands for, the National Elevation Database, NED. So that's coming from our web coverage services at GMU. So we're going to zoom in on all that data here. And the first thing we're going to do is delineate a watershed. Now this is done on the fly on top of the grid. So we're going to pick a point on the watershed. Here we go, real time. And it's now calculating through using the web coverage terrain surface model where the watershed is. And we have a little bit of a problem actually. It's so flat. And something very interesting is happening. I'm just going to pause it in this bottom right-hand corner here. We don't really know what's going to happen there. And really the focus of this thread was to interact between the American and the Canadian databases and see where we could use the database model for the Canadian database in the United States, if an analyst wanted to use that particular data model, or if you're in the US and you wanted to use the Canadian model, there could be interchange there. Plus, to link the features between one host and another. And this is a real thing that we discovered about 3:30 this morning. We were trying to trace this watershed through, and we invoked the WPS that's set up in Taiwan to be able to connect the features here. So we'll do this as we're talking here. This was actually a bed. So the other thing we can do is, before we actually do that, we're going to generate a unit hydrograph. If you've been in hydrology at all, you know, that's pretty complicated stuff, but pretty cool. Boy, you can do it on the fly in a system like this. You can also model the whole watershed because you've got land use, you have the precipitation information, all that stuff is coming together. And this is actually a unit hydrograph that was produced just offhand as one of the pieces of information that we can extract, tertiary information. So here we have this problem, and you can see a little bit of a light line there, but we're not being able to trace this creek or river through the United States. There's a little bit of a line underneath that, but that feature isn't connected. So these are two different features that stop at the border. So we're going to invoke and use the Canadian model to ask the server for the US features and join them up with ours, essentially. And then we can continue on with our analysis. And so we're calling on that WPS right now. We can say, go ahead and get it. And you can see, you should be able to see the line get a little bit darker at the bottom of the watershed as we kind of waiting for Taiwan. Come in. There it is. Okay. So we now have, those lines are now connected, and they're based on the Canadian model. So if I click on that, I get all of the database model in the Canadian dictionary. Okay, so that's pretty cool. We also found when we did that I'm just going to click on here, this is just how we discovered this. If you look at the blue lines over to the right-hand side, I don't know how it's showing up for you there, but it looks pretty strange. Actually, this is so flat that sometimes the water flows one way, sometimes it flows another way. And they have lots of drainage tiles. You'll see as I start to zoom out on this, you'll see where all the drainage dishes are set up there in that Red River Valley area. Lots of flooding problems they have there because it's so flat. Also in the spring, if you've ever been to Winnipeg, bring your off because mosquitoes love it there. So we'll just finish this off now. Take another minute. And so you can see the drainage on the right-hand side. And again, this is because of interoperable services, and particularly focused on hydro. This is the discrete global grid, a representation of it. Now, this is quite interesting because now that we have everything on a grid, we can aggregate information that's coming from different scales. I'm bringing in some trim data here. This is a satellite image, a daily feed of, this is 3 days we're looking at, of a storm passing through the area. It happened in the end of June of last year. And also we have a gridded coverage of population coming out of season at Columbia University. We're going to use that data, we're going to do a little bit of a report. We're going to take the drainage area, the watershed that we delineated, and we're going to say, now aggregate the information that you have in there. So first of all, I'm going to aggregate the trim data, and if you could see this, it actually says, it tells me the minimum and maximum of the what rainfall in that area, and it tells me the average rainfall was about 37 millimeters over the 24 hours. It also tells me the population in that area is 1.5 people per square kilometer. So it's not very well populated, but that's all doing that on the fly. So that's kind of nice. We can also bring up some of the stream flow gauges, and this is actually a precipitation gauge, and it tells us that at the same time, you can see it says 20 and 20, about 40 millimeters of rain fell. So the satellite image said it was about 37, and the actual rain gauge about 42. Not bad. We like to see some things like that. We can also hook up into the stream flow gauge, and we can take a look and see what. Oops. I guess I'm finished. Okay, so I guess I missed. I was looking up, but it showed a hydrograph there as well. And so we could compare our unit hydrograph to the actual hydrograph from that storm. They matched quite well. That was just nice for us. So thank you very much. Some idea of what we can do.
Thank you. Mary? Again, for the hard work they did to get these together. So we're finished with the presentations we did. On our agenda was one last part, which was to just look at the session for questions and answers. If we can provide the answers, we will. Among the participants who are here, it is a hard work to get through where we are today. So, open up for your questions. And also, as we're finishing up, I'd certainly like to invite you to, while time is still available in the room, to visit with the participants who have some demonstration capabilities that they're moving to do. So please take advantage of that if you have questions. And I'll direct them to whoever gets to your question. Before we start, you're overwhelmed, maybe. Thank you all very much for attending today. We appreciate it. We look forward to having more available as the engineering boards hit the street. So thanks again. Appreciate it.